Okay, so welcome everyone to this talk on reactive database mapping with Scala and Slick. I hope you enjoyed the lunch and that after consuming some food you are now ready to consume some Scala code. My name is Jacek Kunicki. I come from Poland. I work for Software Mill, which is basically a software agency, but it's not a typical one because first of all we are 100% remote, so we have no physical office, and we are also 100% flat, so we have no managers at all. So if after this talk you want to talk to me either about Scala and Slick or our flat and remote structure, feel free to catch me afterwards. So this talk is going to be about Slick, so let's say what Slick is after all. Perhaps when coming from the world of Java Persistence API, you are used to a development model when you want to map your objects to a database. For example, I don't know, you have books and authors. You create an entity for a book, you create an entity for authors, and you basically manage the objects. So you don't manage the IDs that are in the database. When you have relations between objects, you manage those objects. So for example, an author entity can have a collection of books. It's not a collection of book IDs, it's a collection of books. And this is called object graph processing. So actually what Slick does is not object graph processing, because Slick is a little bit low level compared to JPA. And we don't manage objects, we just manage the data which is in the database more directly. So actually you can call Slick rather a wrapper around JDBC than a full mapping solution, because it's basically, you may call it a DSL for generating SQL queries to access your database. Slick is sometimes called a functional to relational mapping solution. And of course it doesn't mean that you are mapping your objects to functions, because, well, it wouldn't make much sense. Actually, what Slick does, it provides you, as I said, a DSL, which exposes a collection like API in most cases. So you manipulate your like database mappings, your tables, as if they were Scala collections. So if you are aware of the Scala collection API and methods like map, filter, things like that, you can just use your data as if it was a Scala collection. Another thing which is important in Slick is that the side effects, which in this case is the database access, are fully under your control. So Slick doesn't do any database access under the hood, which this can be problematic, for example, when using Hibernate or other JPA implementations. You may know about the n+1 query problem, where when fetching a list of associated objects, Hibernate can generate like too many queries for you, which aren't really necessary. So Slick doesn't do any magic under the hood. You just manipulate the queries. So you create a query, you can do some transformations like filtering, converting, and only when you explicitly say that you want to access the database, this is the time when Slick runs an actual query on the database. So you may say that the query transformations are lazy, and only when you finish all those lazy transformations, you are done with them, then you ask Slick to go to the database and actually do something with the data. And since it's a Scala DSL, it's type safe, so you have like full control over the types. You cannot make like mistakes related to the type system because you have strong typing while accessing the objects in the database. Slick is also reactive, and in case of Slick, reactive basically means that it's, well, first of all, non-blocking. So every database operation returns a future. So when you call it from your thread, it doesn't block the thread. So like your thread continues going on with what it was doing. You just have a future, which is basically a value but deferred in time. So you may call it a promise that you will receive the value at some point, but not yet. So it doesn't block the main thread. Slick also supports something called reactive streams. The reactive stream is basically an initiative or like an API for processing data asynchronously, not reading everything at all, but like processing stream of data step by step. And Slick also exposes an API that is compatible with reactive streams. Okay, so this is the end of the slides because this was supposed to be a live coding talk. So let's do some live coding now. Since we are at the conference, we're going to implement a very simple voting system for a conference. Can you see the code at the end? So is the font big enough? Okay, no one says they don't, so let's assume it's okay. So in our conference voting system, first of all, Well, we'll start with defining a domain model. So there is no Slick at all at the moment. We'll only use plain Scala case classes to define our domain, so to know the objects we'll be manipulating. So the first object, type of object would be a room. A room will have an ID, which would be an integer, and it would have a name, which would be a string. Now we will also have speakers. And it turns out that a speaker has the same attributes as the room, so it has an ID and it has a name. Of course, at a conference, we also have talks. So our model for a talk is an ID, which is an int. And now we need to have a relation to a room. And as I said before, if we were mapping it using JPA, like Hibernate or just JPA annotations, we would put a room here, so a reference to the case class we defined above. But in Slick, we are like a little bit low level, so we don't work on object graph. We work on the data, which is rather similar to what's in the database. So here we're going to have a room ID, which would be an int, and the talk will have a title, which is going to be a string. Okay, so now you can imagine that we will need a many-to-many relationship between talks and speakers. And this is also something that we want to model in our domain to be able to fetch those associations somehow. So we're going to define a talk speaker class. And once again, since Slick is not about object graph processing, it's rather like a lower level data access. We won't have objects here, but instead we will have just IDs. So we have a talk ID, which is an int, and a speaker ID, which is also an int. Now, to be able to store votes for our talks, we need a domain object for a vote. Now, a vote would have an ID, but in this time we want the ID to be optional. So when creating new votes, we won't be providing the IDs. We want the IDs to be generated by the database, and so we don't want to take care of them. So the ID is going to be an option of int, and it's going to have a default value of none, so an empty option object. Of course, a vote has a relation to a talk, and in this case, it's a talk ID, not the reference to the actual talk object. It's going to have a date, or actually a timestamp at which it was casted. We're going to use the local DateTime from the JavaTime API. And we're going to provide a default value for it, so that when we create a new vote, we don't have to pass the created at parameter every time. And the reasonable default is local datetime.now, so the current timestamp. And the final attribute of a vote is whether it's positive or not. And it's, of course, just a Boolean flag. Now I'm going to define one more domain object to be able to show you later how to fetch actual object graphs. So, normally we're fetching like the data from the raw data from the database, but of course we can also map it then to our domain object and just fetch an object graph as if as we would do it with JPA. So let's have a talk with room case class. And this time you would be trying to restore the object graph and recreate it. So we're going to have a reference to a talk and a reference to a room. And at this time, those are not IDs. Those are references to the actual objects. OK, so now we're done with our domain model. So let's see what the actual database mappings look like in Slick. So the first thing you need to remember about when writing Scala code for Slick is that you need to import the Slick driver API. And this is one thing that you may not like about Scala, because if you forget about the import, you will get some strange compilation errors, but the compiler will tell you everything but that you have forgotten an import. So you basically need to remember about it. And what we'll be importing is the Slick driver. We're going to use an H2 database, so it's the H2 driver, and we're importing the API _, which means everything from the API. Now, to define the mapping for our domain objects that we have just created as the case classes, we would be defining classes for each of the tables. those won't be case classes this time. So the first class is rooms. And now you have to do a little bit of magic. So you need to include something that's called a tag. And it comes from the Slick internals. I'm not going to cover it in depth at the moment because, well, it's not relevant here. You just need to remember that it's some of the Slick internals that you just need to use. Now you extend a table class from Slick's API. You parameterize it with the type of your case class. So the room is the room we defined previously in our domain model. You need to pass the tag object, the mysterious one. And, well, the table needs to have a name, so we provide a name. It will be called rooms. Now we have defined the mapping for the table, but we are still missing the mappings for our columns. So to define the column mappings, we just define methods named after the columns. So our room has an ID, which is a column of int. It has a name, so it's an ID. And we also want to define, like with Slick DSLs, a primary key constraint on this column. So we have an O object, which is like a short name for column options. And it basically provides some fields that you can use to tell Slick how to handle the metadata of the column. So here you can define various properties, like, for example, primary key. So this tells Slick then when we use Slick's API to create the database schema, it would create a primary key constraint on the ID column. Then we have a name, the name column, which is a column of string. It's called name. Well, and that's all. We don't want any constraint here, so that's it. So you may think we're almost done, but we can see something in red here. And the compiler tells us that we are missing a star column or method. And actually, the star method is a way to tell Slick how to select all the records from the table and map it to the domain object, so to the case class, which is room here. So what we need to do now is to define the star method, and we need to tell Slick how to convert a tuple of columns. So in this case, the tuple would contain the ID and the name. Now we have one of the magical operators. And now we need to provide a method, a way to converting the tuple into an instance of our room case class, and to do the conversion the other way around. And fortunately, Scala has those kind of transformations built in. So to convert a tuple into an instance of a case class, we use the tupled method from the case class. And to do the conversion the other way around, we use the unapply method. So tuple takes a tuple and converts it into a case class, and unapply takes a case class and converts it into a tuple. Now we need to define one more object which we'll be using. It's called a query, and we'll be using the query to actually to do the transformations that we want to do, like filtering, mapping, and retrieving or manipulating the objects in our database. We'll call our query rooms. And it's just a table query, which is parameterized by rooms. This time not room, as in the table, so not with the domain object, but with the table that we defined above. OK, now there will be a quicker way to create the remaining mappings, because they are pretty much the same, with some exceptions that I will cover in detail. So the mapping for speakers is the same. The columns are the same. It's just another case class that we are mapping to. Now the talks mapping. There's one more thing we want to do here, because a talk has a primary key to a room in which it takes place, and we want to express, like we will also like Slick to create the primary key constraint, the foreign key constraint for us. So we'll say that a room is a foreign key, since we want a foreign key. It needs to have a name. And now there are several other parameters. First is a source column. So we just need to tell which column from the talks table would be referring to the room, and it's the room ID. Now we have the target table query. So the query that refers to the target table, so it would be rooms. And in the remaining set of parameters, we need to provide first, like we need to provide the target column. There are also other options, but they are not required. So the target column is the ID from the rooms table. And there is also a possibility to define the cascading, like cascading behavior on update and on delete, but we won't be using it right now. But as you can see in the like method parameters, there are some defaults, but you can override them. Okay, so this is for the talks mapping. Now we have a mapping for talks and speakers. And this is basically everything that we've seen before. So we have two int columns and two foreign keys. So we've already seen how to define those. And the last thing we need is the mapping for the votes table. And there are two things we need to adjust here. First of all, since you may remember that the ID of the vote is optional, and we want it to be generated by the database and to be auto-incremented. So here we can use again the column options, which have an auto-inc field, which just tells Slick to make this column auto-incrementable, and it's database agnostic. So we are just telling Slick that we need auto-incrementation, and like the driver takes care of doing it appropriately in the database of choice. Okay, so let's try to compile it. And now the compiler tells us that like the bottom line of this error message is that it doesn't know what to do with the local DateTime column. And the reason is that Slick is aware of how to map like the basic data types to the database, such as primitives like int or string that we had here. It is also capable of mapping Java SQL timestamp, but it doesn't know what to do with the local DateTime. So a solution to this would be to create an implicit value which would provide a conversion between our type, so local DateTime, and Java SQL timestamp, which Slick knows how to handle. So we're creating a local DateTime mapping. And we have, there are some helpers for it. We have a mapped column type object with a base method. We parameterize, it has two type parameters. First of all is our local DateTime, and the other one is the one we are going to convert to. So it's Java SQL timestamp. And we need to provide two functions here. First function would tell how to convert an instance of a local DateTime to a timestamp, and the second one would do the conversion the other way around. So having a local DateTime, we can say timestamp from, and now we convert the local DateTime to an instant. And the only thing that we need to provide here is a zone offset. And I wrote zone offset.utc here, but it's certainly not the thing you should do in production, because especially when you're dealing with multiple time zones, like defaulting to UTC may be at least dangerous. So in this kind of mapping, you need to always remember to handle the time zones correctly. But here UTC is like a reasonable, shortcut to take. And the conversion in the other way is simpler, because timestamp just has a local DateTime method. So we can use a shortcut notation with the underscore, which is like the default parameter of the lambda expression, actually, or the anonymous function. And now when we run the compiler, it wouldn't complain anymore. So now Slick, with this implicit value, Slick already knows what to do with the local DateTime column. And the last thing I'm going to define here is a helper variable with all the database schema, with schemas of all the tables. We will be using it afterwards to manipulate the schemas. And basically, every query that we created before has a schema method, which is basically a list of the DDL operations that need to be performed on the database to create the table. And there is an ++ operator overloaded, which just concatenates the schemas. So we need to take speaker schema, talk schema, talk speaker schema, and votes. Sorry, of course those are no commas, but the ++ operators. It's not a sequence. It's a chained invocation of the concatenating method. Okay, so Now we have our domain model that we defined previously. We have a mapping of our domain model to the database tables. So let's see how we can populate our database with some initial data. So as I said, you need to remember about the magic Slick driver import to be able to use all the database objects. And now our initial data trait needs to be aware of two things. First of all, it needs to be aware of the database schema. And the self thing here is something called a self type in Scala. And it basically says that any class or trait, anything that inherits from initial data, also needs to inherit from database schema. And this gives, like in compile time, it gives us access to all the database schema objects and methods within our initial data trait. And the second thing we need to use here is the database. We'll get to it later, like how to create an instance of the database object. Here we just define it as an abstract method. So now we're defining an insert initial data method, which, since, as I told you before, all the database operations are non-blocking, so this method is going to return a future, and it's going to return a future of unit, which is like a void in Java. So it basically, we don't care about the result, we just want it to be a future, but unit is like void, so it's nothing which would be of interest for us. And the equals is missing. So as I said at the beginning, in Slick, we first define the queries, do all the transformations on the queries, and only when the queries are ready, we actually run them against the database. So here we'd like to run a sequence of queries, so not a single one, but many of them. And for this, we have a helper, a dbio-sec method, which basically takes a sequence of dbio actions. So the queries in Slick are called dbio actions. So you are manipulating the dbio actions, composing them, and then running them against the database. And dbio-sec basically takes like a sequence of database actions, like this is a var method, and combines it into a single database action that can be run against the database. So since we'll be using this method many times, like I'll be running my main method multiple times, and we'll be recreating the schema and the data every time. So we want first of all, we want to delete all the data we have in the database. Actually, we won't be creating the schema multiple times, but we'll be inserting the data. So first of all, we are running the queries for deleting data from our tables. We need to take care of the proper order here so that we don't violate the foreign key constraints. So first we delete from votes, and it's a var method. So this time we're not using the ++ operator to concatenate, but we're just providing the subsequent queries to run or the database actions after commas. So we're deleting from votes, we're deleting from talk speakers, we're deleting from talks, we're deleting from speakers, delete, and we're deleting from rooms. So now that we have the initial state of the database, like the tables are empty, we can actually insert some data. So first, let's see how we insert just a single record to room. So how we add a room. So we just say rooms plus equals. Here we say room. So we just provide an instance of our case class from the domain model. So once again, rooms here is the table query we defined for our table mapping. And the room here is just the case class we defined at the beginning, so in our domain model. We can add another room. And of course, like adding, if you need to add multiple objects, adding them one by one may not be the most useful and comfortable solution. So let's see how we can add multiple objects at once. And here we are just using, instead of plus equals, we're using the ++ equals operator for speakers. And we can provide a sequence of our case classes to add them to the table. So here we say speaker 1, speaker 1. Let's add 2 more speakers with some dummy IDs and names. And we also want some talks. So this is pretty similar. We are once again using the ++ equals method and adding a sequence. And we want some data for the talk speakers mapping, which is once again the same. We have a case class in our domain model to express the mapping, and we are just adding instances of our case class. Okay, so we have a way to adding the initial data to our database. So let's now try to run the code and see if it actually does something useful. So to run our code, we'll be using a main method, a main class, which is an application, Scala application, so you can just run it. Of course, we always need to remember about the driver import to be able to use the database-related stuff. And now we want our application to be aware, first of all, of the database schema. We want it to be aware of the initial data trait we just created. And since our time is limited here, we're also going to use some magic to help us get around. And the magic trait is actually not that magical, as it may seem. It does two things. First of all, there is a create schema if not exist method, which does a query on the database metadata. So the mtable.getTables just retrieves all the tables from the database, from from the schema. And if it is empty, it uses the all schemas variable that we created, the helper one, to just run the create query on all schemas and create the tables. If the list of the tables is empty, it just does nothing and it says that the schema already exists. And another helper method, because we'll be dealing a lot with futures a lot here, is a helper that when given a future of an iterable of some type, waits for the future to complete, so does a blocking call await.result, and it waits infinitely and basically prints out all the elements of the iterable and a new line. So we'll be using those helper methods to see what's actually happening. Okay, so the first thing we need, and this time the compiler also complains that we need an instance of a database, because in initial data we defined an abstract database method. So we're going to create a database, and we're going to use configuration. So Slick has a helper method to just load a configuration file and fetch the database config from there. So it looks like that. And the actual configuration is here. So the T-SQL part at the bottom is not relevant. You only need to look at the H2 part. And it's pretty straightforward. We just provide a JDBC URL, the JDBC driver, and some additional properties. And from such configuration, we can already have an instance of a database created by Slick. So now we are going to do two things. First of all, create the schema if it doesn't exist. And then this returns the future. We want to wait for the future to complete. And when it completes, we want to insert the initial data. So we cannot insert the data before the schema was created, because, well, there wouldn't be a place to insert the data. We need to wait and then execute another set of statements. So to wait for a future to complete in Scala, we can use the flat map method. The underscore here says that we don't care about the result of the create schema if not exist. We just take care of the fact that the future has completed. And afterwards, we do the insert initial data thing. Now we can store it in a variable. And well, I told you that all the database calls are non-blocking. But of course, in our code is synchronous, like our simple application. So there is we need to block at some point. Eventually. So we would make a blocking call here. Actually, we don't care. We don't care about the result of the future. We just care that it has completed. Normally, well, you need to provide a timeout, and you should be providing a timeout when doing any blocking calls. Unfortunately, the Scala API for futures and for making the blocking calls on futures requires you to provide a timeout. So this is a good practice, and here the API enforces it. So if you have an API that does not enforce timeouts, you should still think of it and use timeouts when you do a blocking call to something. Here we will be waiting indefinitely, so this is like not too elegant solutions, but it's enough here. Okay, let's try to run it. And it doesn't work yet. Why? Because we are manipulating the futures. So we want to do like wait for a single future to complete, then do something else. But in Scala, we need to be like explicit about the thread pool the future operations are using. And in Scala, a thread pool is defined by an execution context. And what the compiler tells us here is that we didn't provide the execution context, so it doesn't it wants us to tell it how which thread pool to use for executing the asynchronous operations. So again, we are going to do something quite unsafe here. We're going to use the default execution context. Implicit global. It's a global one. And normally it's not a good practice to use the global execution context because it may be used by various internal operations. And when you accidentally block the global execution context by your code, you may block the entire applications. For example, you may run out of threads or things like that. So it's always best to have a well thought thread pool that you know what you will be using it for, and to define it appropriately. But here, once again, for the purpose of this demo, we'll just be using the global execution context. Oh, and I told you that we define queries and then run them against the database, but we actually forgot to run them. So we have the database object defined here, which has the run method, and it takes a DBIO action, as you can see, so we need to pass the queries here that we just defined. Okay, so now since the database was empty, it told us that the schema was created. When we run it once again, it says that the schema already exists. So far, so good. So we have the domain model, we have the database schema, we have a way to populate the database with some initial data. So let's now see how we can manipulate the data in our database. Or actually, first we will start with different ways of querying the data. So we have a data access object, and of course, the thing you start with is the API import. Now our data access object would have a dependency on the database, and it also needs to be aware of the database schema, basically to know about the table queries we defined and we want to use. So the first method we want to define is to show how do the joins in Slick in various ways. So we'll be fetching talks with rooms. And since the call would be not blocking, we'll return a future. And the type of your future will be a sequence of tuples. We want to fetch the title of the talk and the name of the room. So this would be a tuple of string and string. So we'll start with defining a query. And now we'll be fetching we'll be combining two table queries, the talks and the rooms. So now we could use flat map for that, but it would be easier to read when we use for comprehension, which is basically a syntax sugar for maps and flat maps. And we say that we want to get data from the talks table. We want to take from the rooms table. Here we have a condition that the ID of the room needs to be the same as the room ID of the talk. And we want to produce the talk of the title and the name of the room. Now, please notice that here it's not a double equals operator from basic Scala API, and actually it's an operator from Slick, so it's a triple equals, which does the comparison on the table columns. And now we just need to run the query against the database. And like the select queries, so that the queries that fetch data are not database actions themselves. To convert a query into a select query into a database action, we need to call the result method on it. and then it becomes a database action that we can run against the database. Now we're also going to get the statement, to see the statements which actually get generated by Slick. And we're just going to print them out to see what happens under the hood. Of course, this can be done with setting a proper logging level for Slick internals, but you can also do it with the statements method, so let's just use it here. And now going back to our main method, first of all, we need to create an instance of the conference data access object, passing the database. We'll be using the print result helper method from the magic trait, which takes a future of iterable, waits for it to complete, and prints all the results, like all the elements of the iterable. And we're going to fetch talks with rooms. Okay, so we have the query. It actually looks pretty nice, especially for a query that was automatically generated. And we have all the data we wanted, so we have a sequence of tuples. Now you may remember that in the rooms table, in the talks table, we defined a foreign key to rooms. So actually, instead of giving this if constraint here, we can just say that we want to fetch the room from the talk we have at the moment. So this room here is the foreign key that we defined in our database mapping, and we can use it as well. So the result would be the same, the query would be the same, but it's like we're using just the helper that we created. Okay, so now this is one way of doing joins. Let's see how we can do a join in a slightly different way. Now, this is certainly not a clean code with the talks with rooms too, but let's just stick to it. Of course, it would return a future. This will be a future of sequence, but this time not of tuples, like the string, but this time we're going to use the talk with room case class to fetch to return the actual objects. So not just properties, but all the full instances of our case classes. So talk with room is the case class from our data model, the domain model, which has like references to the actual objects. Once again, we're going to start with a for comprehension, but this time we'll be fetching like data from both tables, let's say at once. So we're going to have both talk and room here. And now there is a way, like there is a DSL which lets us write the join almost in plain English. So we can just say talks join rooms on, and now we need to like provide the columns on which the join would take place. So the room ID of the talk needs to be equal to the ID of the room. And once again, this is the triple equals operator, so it's a like sleek operator, not the default Scala one. And since we want to like get our full domain objects, here we're going to produce or yield the like entire table and the entire room. Now the code to run it and like to print the statements and run them is pretty similar. But we can see that something is still wrong here. And the problem is that our query returns a sequence of tuples of a talk and room, because that's what's produced with the yield clause in the for comprehension. But we actually want a sequence of our domain objects. So fortunately, we can map it quite easily. And here we need to make two map operations, because since the run method returns a future, the first map we are doing here is on the future. It's not on the result that is inside the future. It's on the future itself. So we want to transform the value which is inside the future. And here we have access to the actual content of the futures of the sequence of tuples. We are going to access it with the underscore, so the default parameter. And this sequence of tuples we want to map to instances of our talk with room class. So actually talk with room is a case class, so it has a tupled method. And as we've seen previously, we can use the tupled method on a case class to make an instance of the case class from a tuple that like resembles the schema of this case class. So let's get back to our main class. And let's see the result. And once again, the compiler complains that we are manipulating the futures. Here we are doing we're doing a map on a future, but we didn't provide an execution context, so we didn't specify which thread pool to use. And once again, we'll use the dirty way to do it, which would be using the global execution context, which is what you shouldn't normally be doing. Okay, so we can see that the query is a little bit different because we are fetching all the columns from the table, not just two of them. Actually, as expected, we have the instances of our talk with room case class. So that's what we wanted here. So this was the way to do some more complicated, let's say, select queries, which were joins. Now let's see how we can add some data to the database. Actually, we've already seen it in the initial data trade, but here I want to show you like a more complex case with related to the ID generation and stuff like that. So we're going to have an add_vote method, which would take a vote, an instance of our domain model case class, and it will also return a future since it's gonna be no blocking. And this would be a future of vote. And basically what we want here is to like pass a vote with only the like non-optional values specified, so particularly without the ID. And we want to get back a future of vote that would contain the ID that was generated by the database, so that we can see that the ID was actually generated. So if we only wanted to add a vote to a database, we would do it similarly like in the initial data trade, so we would just say votes plus equals vote. But here we can see that and we would run it. And now the queries that manipulate the data are already database actions, so we do not need to use the result method. We can just run them against the database. But well, this mysterious message basically tells that by default the insert query would return something called single insert result, and actually we don't want something like a single insert result. We want an instance of vote. The default behavior usually is to return the number of rows that were affected by the query. So in this case, it would actually return an integer, which would tell us how many rows were affected by the query. But we want to do something more complex. We want to fetch the ID that was generated. So let's extract a variable and call it votes returning ID. And now what we do is we say that we want votes returning. And now we want to return the ID. And in Slick, if you want to tell Slick to fetch a particular column from a table or to do something with a particular column, you need to use the map method on the table query. So our table query is votes, and we map it to the ID column because ID is what we want to fetch. And now we'll say that now we have the ID, but we don't want just the ID. We want the full vote with the ID updated. So we say into. And now we have a method that we need to provide a method that takes two parameters. First of all, it takes the table element type here is a vote basically that would be returned, but we don't care about the vote because well we already have an instance of the vote in the method parameter in the add vote. But what we care about is the new ID that was generated by the database. And given this tuple, so with a single element that we care about, so the new ID, we want to like convert the vote that we received in the method, so this one, without the ID, into a vote that actually contains the ID. And to do such conversion, since case classes are immutable, so we cannot just say vote set ID to something. Instead, we need to create a new instance of the vote, so we need to make a copy of it with the ID field set to the new ID. But it's still not it, because the ID is an optional field. So we need to write it. We cannot just pass an int. We need to wrap it in an option. So in a non-empty option is called sum in Scala. So we say sum of new ID, which is a non-empty option containing that ID. And that should actually be it. I just define one more helper method that we're going to use in the future. It's find all votes. And this would return a future, once again, of sequence of vote, so of our domain model. And this is actually the most straightforward query that you can imagine, because we'll just say db.run votes result. So this is how you do a select star method from the table in Slick. So there's nothing nothing complicated about it. Okay, so now we defined a method to insert votes in our to our database. So let's actually use it. And I won't be writing this entire code since it's really not necessary. But what we are doing here is basically we have a method that takes it has a sequence of votes. So it's a sequence of our vote domain objects. And what it does afterwards is just inserting all the votes into a database. So you have there is a lot of future manipulation here. And basically, the reason we need it is, I'll just show it to you, is that the new votes, when we map the new votes to the conference DAO add vote method, we'll have a future of vote for every single vote. So what we'll get here is a sequence of futures. But actually, we don't want to wait for every single future. Instead, we'd rather have all the futures from the sequence combined into a single future that we can wait for. And that's actually what the future sequence method does for us. Because when we check the types once again, what future sequence does, it takes the sequence of futures, so a future, another one, and it combines them into a single future that contains a sequence of the results. So basically from a sequence of future of vote, which we have here, we are converting to a future which contains a single sequence of all the votes. So that's the a bit of magic that's happening here. So now, since we have defined the voter, we need an instance of it. And the voter needs the data access object as a dependency. The voter vote method would return the sequence of the votes in a future with the IDs generated. So actually you want to wait for the futures to complete and to print the results. So we want to see that the votes that were returned back by the voter actually have the IDs generated. So that's why we'll be using the print results method here once again. And you can see that, one more thing you perhaps noticed that already, that the votes that we defined here just have a talk ID and the positive flag. They have neither the ID nor the casted add date, but as you can see, they are generated here. So the votes that we have here have both the casted add date generated and the IDs as well, and the IDs were returned from the insert queries. So it works as expected here. So now we've seen how to do joins, how to do updates. Let's see how we can make. Well, actually, we didn't see how to make updates, and that's what we are going to see now. We've seen inserts so far. So our update method will be we'll have a positive attitude. It would make all the votes positive, so that everyone gets good notes here. As always, we start with defining a query for the database.
Just a couple more minutes.
Okay. Okay. So we take our votes and let's say we want to optimize here and only update the votes that are actually not positive. So here's an actual collection operation from Scala. We just do a filter not, and we filter by the positive columns containing false. Now we want to update the positive column. So to update it, we want to tell Slick that it needs to operate on the ID column. So we do a map to the ID column, and now we update it to true. And we can just run the query. We can actually, what's wrong here? For each print line, it's votes. Sorry, we don't want to update the ID.
Maybe going to the questions.
Well, okay, well, I can either go to questions or show one more thing, so it's basically up to you whether you want to ask questions or see one more thing. You can always catch me later for the questions, so like does anyone have a question, or do you want to see one more thing? Okay, so it's positive that we're going to use here. Now we're going back to our main method. And we want to like print results. We want to make all the votes positive. This returns, and we want to wait for the future to complete. That would do the update and then fetch all the votes. So once again, we do a flat map. We ignore the result. And we say, find all votes. And you see that all the votes are now updated to true, and the query is also pretty straightforward. So let's see one last thing, which we can do with the slick DSL. And this would be about aggregation, so grouping, sorting, counting, things like that. So we want to count positive votes by talk. And this will, well, it will return a future, and it will be a sequence of, it won't be a sequence actually, it will be a map from string to int. So basically we want to have the talk title and the number of positive votes that the talk has got. So first of all, we're going to query for all the talks with positive votes. And we're using the for comprehension here. We're querying from talks and votes. And we'll say talks join votes. And actually, we've just made all the votes positive, but let's assume we didn't, so that we only want to fetch the votes that have the positive flag set to true. And the join criteria is the ID of the talk needs to be equal to the talk ID of the vote. And what we want from here is the title of the talk and the ID of the vote, because, well, we basically need to count, so it doesn't really matter which column we fetch from the vote. Now we want to group it by the title of the talk. So we take the talk with positive votes, and we want to group it by the first element of the tuple. So we have a tuple of a title of an ID, and we want to group by the tuple. So it's _1. It's like the reference to the first field of the tuple. Now we want to count the votes by talk. And here we need to do a map. And within this map, what we receive after grouping is the title of the talk and the IDs of the votes. And we want to convert this tuple, well, we want still to have the title, and we want to have a number of votes, so it would be vote IDs dot, it should be vote IDs dot size. Oh, I forgot the case here, because it's pattern matching, so yeah, now we're good. And the last thing we'll be doing is sorting it by the descending order of the number of positive votes. So we'll say counted, sort by. And now we want to use the second field of the tuple, so it's _2, and we want it to be descending, so we just say desc. And actually, we can say db run sorted.result, because it's a select statement, so we need to run the result method to convert it into the dbio action. And there is one more problem here, because our method returns a sequence of strings and ints, but we want a map. Fortunately, it's easy to convert it because when we have a sequence of tuples, we can just call the toMap method, and it will convert it to a map. So now we just need to run it. Okay, we can see that it actually did the count. I'll just show you the query it has generated because, well, now it's not that pretty as we may expect, but well, that's the problem with the code that gets automatically generated. For each print line. And of course, perhaps they could do it better. Actually, that's the main thing they are working is still working in Slick. It's improving the query generator because you can see a nested select here, and perhaps you could do it much easier with plain SQL. Okay, so that's basically everything I had. All the code is available on GitHub. If you want to play with it, there is a short description how to run it. If you have any questions, you can catch me later. You can catch me on Twitter, and feel free to look at the Slick documentation at Lightband. And if you want to see the code on GitHub, you actually need to go to the Java 1 branch because, well, on master there is a bit extended version, but on the Java 1 branch is exactly the code I presented here. Thank you very much for your attention.